We are going to start looking at probability. We are going to start looking at probability. This topic is very important. Probability, at every stage of mathematics, you discover the importance of learning probability. Probability is a topic that is very essential, as in life so many things happen. There are so many events to be predicted. In each case, we talk about the likelihood of an event to take place. And this is what probability is going to address, the likelihood of an event taking place. With this, we want to approach it mathematically and see how you can actually calculate probability at your level. This stage is level 2, functional skills mathematics. And the important factor we're going to look at is how do you calculate probability. And what is probability? Many events can't be predicted with total certainty. They can't be predicted with total certainty. But the best way we can actually look at this is how likely they are to happen using the idea of probability. I will draw here a chart. Hopefully this can help you in understanding probability. Run with me very quickly. Okay, what is probability? It is the likelihood, okay? It is the likelihood of an event, the likelihood of an event to take place. Let's make it that simple, okay? To take place. If we define it that way, probably it will help us to understand the kind of computations that we need to go through. I will draw here probability line. Probability is always between 1 and 0. And half of the line is 1/2. What that means, if the event can never take place, it will come under the 0. Here we say it's impossible, okay? The event at 0, it means it's impossible. It's what? Impossible. It can never take place. If the probability is at 1, we say it is certain. So if we say this is gonna happen whether you like it or not, so the probability of that happening is certain, which is here at number 1 here, okay? If the probability is that this thing would never happen, then it is 0. Now the interesting matter of life is that some things lie between 0 and 1. We have an event over there, so it's very close to 0, so this is very unlikely. So okay, I put very unlikely. So very unlikely. In other words, the chances of this happening is very true. It might just happen, but look at the scale. It's no longer impossible, but very unlikely. Then we'll move up a little bit further. So things are changing slowly. We move up, let's say, this is 1, 2, 3. Yeah, 3/4 up the way. It is unlikely, still unlikely. Can you see? We are measuring very unlikely, unlikely. As we approach here, things are happening, begin to look different. Let me just wrap up this bit here. I want to show you exactly how this probability works before we get some examples to compute so that you can understand the topic. So I would say here it's unlikely. Okay, we're talking about probability. This is very unlikely. If you're writing notes, if you're writing notes, you can copy this diagram at your level. We need to understand this. Unlikely. Okay, very unlikely, unlikely. So it's changing impossible to very unlikely to unlikely. Then as we approach half, so now we say even chance. What does it mean? Even chance. So the event can take place 50-50. It can either take place or not take place, but the answer is 50-50. You've heard of that. That's probability. Now, the moment we cross the half here, we begin to talk about, let me 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the moment we cross the half, here it changes. The events are now likely. What are they? Likely. Once we get to the third 1, 2, 3, 4, the 3/4 way, up the way there, it becomes very, very what? Likely. It might seem a bit confusing if you're looking at probability for the first time, but this is how the scale works like. When we do some questions, you find it so easy to understand. So, probability in essence is measuring the likelihood of things to happen or the unlikelihood of things to happen using the timeline. I'll call it the timeline between 0 and 1. So all probabilities at the end of the day must add up to 1. Okay? They should never go beyond 1. Okay? They should always be between 0 and 1. So let's have a quick look at a good example. And from this, we are going to define how you can actually calculate probability. Okay? Here's an example. What is the likelihood of rain coming tomorrow? What chances does she have of winning the 100-meter sprint? All those are probability questions. Is there a risk that his company will go bankrupt? Those are probability questions. But they cannot be answered in isolation. We've got to look at the whole scenario. And we can say you can give a value to enhance the chance of any of these outcomes or events happening, and millions of others as well. This value is called the probability. If we say the probability of it raining is 1 out of 2, or it's going to be 2, it's going to be the other value above 50, above 1 out of 2. And I'll show you how these ones are worked out. Okay? There must be a value to it. Let's have a quick look at one of the examples. This will help us understand probability so that you and I can fly together in this probability lesson. I'll give an example of the following. if I gave you, let's use a coin, okay? Coin has got heads and tails. When a coin is tossed, yeah, when I toss, okay, when I toss the coin, okay, what outcomes do we have? What are possible outcomes do we have? Outcomes. The first outcomes could be head or tail. So there are only two possibilities. Tails, sorry, there are only two possibilities here. I go over again. There are only two possibilities. Heads, the coin can come as heads, or the coin can land as tails. Why? Because there are only two possibilities. There's a head and a tail. That's all. So we say, what is the probability? The question arises, what is the probability of having a head? Let me bring. So, question, what is the probability, probability, okay, what is the probability of the what? The coin doing what? The coin landing, yeah, landing what? Heads. What's the probability? How many possible outcomes? They say total outcomes. We've got H or tails. This is 1, 2. So total outcomes is 2. How many heads do we have here in total? We've got only one head and one tail. So the probability of landing a head, okay, is going to be 1 out of 2. Because this is the total of possibilities. One for head, one for tails. So the totals, if you add these two together, is 2. Then the outcome that's desired is head, which is only 1. So the probability of landing a head is 1 out of 2. If you go back to the table that we wrote before, this is the scenario that you find. Okay? So I'll just go to the next screen. I forgot I could do that. I'll just go to the next screen. So equally, what is the probability of landing a tails? Because there's only one T, the probability is the total outcomes was 2, is also half. So in this example of the coin, so we say probability, okay, probability for H is equal to 1 out of 2, and probability for T is also 1 out of 2. If you go on the chart we draw, these events have equal chances of happening. So their probability is that 50-50, either head or tail will land. So that an event is assured. There will be an event happening. but that event is 50-50, or it is 1 out of 2. Let's go now, have an example before we actually now write the actual formula of how to calculate a probability. Let's use another example too. Maybe this might help you a lot. Example 2, we're looking at probability. Let's use a classical throwing dice. Okay, I'm going to use blue here. Throwing dice. Throwing what? Throwing what? Dice. Anybody knows dice? Yes? Okay, I'm going to just draw a chart and show you the possible outcomes from a dice. A dice has got how many sides? 6 sides. Let's go 1, 2, 3, 4, 5, and 6. Let me make this table a bit longer. This is very, very interesting, and observe very closely what I'm going to do here, okay? So this is a dice with its 6 sides. Now the first number is 1 with a dot, yeah? Correct? Indeed. The second number is 2, only 2 dots. Then we've got 3, it's always like that. Then we've got 4, okay? Then we've got 5, they dot them like that. Then we've got 6. Okay, so that's a dice. It's actually a very nice cube thing with numbers 1 there. I think 3 is over their side. There's a 2 there, of course. You've got a 6 there, and so forth. But if you rip it apart, you open it apart, it looks something like this. Okay, so we have, what is the total if I throw a dice once? Count how many faces we've got here. Face 1, 2, 3, 4, 5, 6 faces. There are, how many are there in total? 6 faces or sides. That's all there is. So the total outcomes or events for this one, if I throw it once, it's got 6. 6, no, total faces, yeah? Total faces, yes? So total faces, let me not confuse you. Total faces, it's 6, right? It's 6. So if I go back here, you see, out of that 6, the chances, if I throw the dice once, if I throw the dice once, yeah, if I say probability of getting a 1, we go back here. What's probability of getting a 1 to land this number here? If I throw the dice, what's the probability that I'm going to get a 1? Simple. We look at how many 1s are here. There's only 1 here out of the 6. So it is 1, 2, 3, 4, 5, 6. You get a point? Out of the 6 faces, there's only 1. Yeah, there's only one chance out of 6 for this to land. What about for a 2? What about for a 2? If you go back again, 2, there's only one of it. So it follows that a 2 for a 2 is also 1 out of 6. Similarly, for the others, because there's only one each of that, it is still one chance out of 6. If I throw it once, yes, if I throw this dice once, it can land either on 1 or 2 or 3 or 4 or 5 or 6. So the probability of me having any of these numbers throwing a dice once is 1 out of 6. For me to land a 6 is 1 out of 6. For me to land a 5 is 1 out of 6. You get the point? So from this, it follows that we can define the probability of getting any of the numbers from a dice as we say for the dice, yes, this is the dice, right? The probability of any one of them numbers, yeah, is what? 1 out of 6. Period. End of story. Because there are only 6 chances, and each of these numbers has got equal chances, 1 out of 6. Now, let's give a general definition. We can say, therefore, we can define probability as number of ways it can happen, okay? Number of ways, yeah? Number of ways, let me just leave space for myself to write properly there. We can say number of ways it can happen, okay, divided by, I put red, total what? Total number of outcomes. Total number of outcomes. As we saw, the total number of outcomes in our dice is 6, because there's got 6 sides. That's all. Then the number of ways it can happen for each of these numbers to come out is 1 way. There's only one way that we can have a 6. There's only one way that we can have a 5. If there are more than 2 bits of 6s in there, so 6 will have 2 chances. But there's only one chance for each one of these. Yes? You can see clearly there. Each of these has only one chance. One chance out of the 6. So the total population is 6. That is how we can define probability. So this makes life easier. Now let's do one question. Let's do one question. Let's do one question. Here we go. Is that clear? Excellent. So the other way, I'm going to give an example. I'm going to say there are 5. There are 5 marbles. How many marbles are there? 5 marbles. You know what the marbles are? Yeah? In a bag. There are 5 marbles in a bag. Now look at this. 4 are what? Blue. No, that's not blue. 4 are blue. Okay? Then we have 1 is red. Here's a question now. What is the probability that a blue marble gets picked? What is the probability that a blue marble, you understand? A blue marble gets picked. A blue marble gets what? Picked. You've got to be very attentive to the question and the question mark there. I go through. There are 5 marbles in a bag. How many are they? 5. 4 are what? Blue. 1 is red. So we've got total of 5, and the statistics is given to us. That's important data, saying that of these, 4 are blue and 1 is red. Now we say, what is the probability that a blue marble is picked? Very quickly, remember our definition. Probability is number of ways it can happen divided by the total number of outcomes. Naturally here, when you look at this one, 5 marbles, there's no way we are going to exceed 5. If we put our hand into that bag, we're going to encounter one of these 5 marbles. Certainly. Now, what is the probability that a blue marble gets picked? Now, let's use a diagram so that you can see clearly. I'm going to draw this is my bag, okay? Here's the bag, and watch carefully. It's a pretty nice one, isn't it? Got no handles. So, we have, how many marbles are there? There's 5. 1, 2, 3, 4. 4 are blue. And I'm going to shade them blue so that you can visualize. This topic is not as difficult as it sounds, as long as you can visualize. And then, how many reds are there? Only 1. And we're going to shade it. Now, if you dip your hand into this bag, you can see what are the chances that I pick a blue. There are how many there? There's 1, 2, 3, 4. Any of these marbles can be picked. So the probability would be, you draw a line like that, the total number of outcomes is 5, because we are told there are only 5 marbles. So if I dip my finger there, my hand there, and I want to pick a blue, or even if I didn't want to pick a blue, I dip my finger, what's the likelihood that the one that comes out is a blue one? Because there are 4 chances, any of these 4 can be picked, so I put 4 on top here. number of ways it can come out is 4. So the probability now for a blue is 4. The way you write your answer is as follows. So you're going to say probability. Did you see that? Probability for a blue is going to be 4 over 5, which you can also simplify. Your short division, remember, how many 5s in 4? You put 0, place order 0 there, then you add a 0, and then 5s in 40, it's 8. So it's 0.8. So if you go on our timeline, remember the diagram that we drew. Yeah, here's 0, there's half here, there's 1 here, there's 1 here. So 0.8 here is 0.5, so 0.8 should be somewhere here. So 0.8, so you can see the likelihood of this happening is very high, isn't it? So at this stage, this is how you calculate the probability. Very clear? If I asked you now, what is the probability of taking a 4, a red one, is simply 1 out of 5. Because a red one can only happen in one way. There's only one chance of red. That's how we work out probability. I will give you an example. Before I give an example, I just want to emphasize this point. Probably end the story, start on another section. In other words, I'll say probability is simply a guide, okay? Probability is what? Probability is just a guide. It does not tell us exactly what will happen. It's just a simple guide, okay? So a guide helps people to plan, okay? A guide, because it does not, you know, the weather, it does not tell us exactly what will happen. You see, even in that bag, if you're doing a competition, right? So, or if you pick a blue, you get 4 marks, or 4 points. I could just put my hand in there, although the chances of blue ones is higher, I might pick a red, and I win the game. But in what they say, odds, those who do betting, they can look at statistics, and they count how many times this team has won. They think, oh, no, out of every 10 games, they do score 3 goals, or out of every 10 games, they win 5 games. So they are now basing their probability on historical events, and they can work out the likelihood. But that does not mean that's what will happen. It's simply a guide. With this, I would like to end this part of a session. I will give you some questions to work through, and I trust that you'll have learned something today on how we do simple calculations in probability. Let me just go back to the first screen and summarize with that. So any questions, since it's a session that is also on your e-learning afterwards, you can bring them up through your tutors. Probability of the coin, we looked at that, 2 sides only, the total outcomes is 2, so the likelihood of heads coming or tails is half, because there are only 2 sides. And then we looked at the throwing dice. Dice has got 6 sides, and therefore their total outcomes is 6. But the number of ways each of these numbers can take place is 1, because each of these numbers is represented once on the dice. Then we come to the example which went through, and that is the way the formula for calculating probability is equal to number of ways it can happen, which is the numerator. Denominator is going to be the total number of outcomes. Just work out the total number of outcomes. The example of the marbles, there are 5 marbles in the bag. 4 of those are blue, and 1 is red. What is the probability that a blue marble gets picked? It's a matter of counting the number of outcomes and also how the number of ways this can happen. For the 4 marbles, it's 4 ways because there are 4 chances, because there are 4 marbles in there, so 4 over 5. And for red, it's 1 out of 5. And probability is also worked out as a decimal. You can use short division to get your final answer, and you can place it on the scale and see where it leans. And finally, we say that probability is just a guide. It does not exactly tell us what will happen, but you have that kind of information to help you plan. Thank you very much, and I'll speak to you again.